Hello, we are the Crowd Particulate Matter Capstone team. My name is Jaron Rosenau. My teammates are Jack Armstrong, Skylar Soon, and Mark Sparhawk. Our project partner is myself, as I propose this project to the instructional team. CrowdPM is a crowdsourced air quality platform where particulate matter and other gas sensor nodes upload geolocated readings, and users can view approved public data on an interactive 3D map. Our platform architecture starts with a sensor node that connects to our Firebase function through a REST API. From there, the metadata gets stored in the Firestore document, and the gzipped batch payload goes in the Google Cloud storage. From there, we use a React website to view the public 3D map and the data.
From the user perspective, the core feature here is the map. In the fall, I worked to set this up, did some radix and tailwind styling, general map styling, and was experimenting with a CAM's PM 2.5 heat map that we ended up scrapping. But later on, I helped improve the general map UI, added a ton of different pages like the pairing information page, team modal, about page, node page, did a general map UI revamp, and added like the hamburger menu on our site. And just recently in the spring, I added some more improvements such as the free mode versus track mode and other filters in the batch sub window.
My work focused on user workflows, testing, and admin usability. In fall, I added Firebase auth modals, the user dashboard, and batch cleanup behavior for the early smoke test admin flow. In winter, I added backend route test suites, including activation, measurements, and other API routes, and documented the test structure in tests.md. I also worked on local emulator workflow fixes, saved device IDs for faster local ingest testing, and fixed privacy-related batch fetch issues. In spring, I added reusable pagination for the dashboard and moderation lists, saved map zoom and timeline state per user, and added front-end/back-end support and tests around batch selection.
Yeah, and the most important user-facing result is that CrowdPM is no longer just an API or some sort of data store. Users can actually explore public air quality data, understand how pairing works, view project information, and interact with the map in a more polished way.
The project also includes the account and ownership layer. Users can sign in, manage devices, review batches, change visibility, and delete their own data. Admins can moderate submissions and users. This matters because PM 2.5 readings include location data, so access control and visibility rules were part of the product, not an afterthought.
The device side was one of the harder parts of the project. The pollution sensor node has to pair securely, receive approval, register with the platform, and request access before it is permitted to upload pollution data. The emulator helped us test that flow without the need for physical hardware. This let us validate the end-to-end pairing ingest workflow and simulate data on the platform more consistently.
After thinking about scalability, I came to realize that we were storing every batch as a new Firestore document, which was not scalable. And so instead, we refactored the storage design and put the batch in a cloud storage object with the metadata in the Firestore document. The result is a lower cost and better scaling. There's no one document per point explosion. The public map reads the metadata quickly. The full payload stays available for viewing and exporting, and the moderation and user ownership continue to be effective.
Testing was a major part of reaching release candidate quality. We used vtest for backend route and service tests, plus manual black box checks for sign-in, activation, ingest, map visibility, dashboard behavior, moderation, and checkout. We were not doing pure test-driven development, but testing became more important as the system grew. One major design deviation was storage. Instead of storing every measurement as a separate Firestore document, the final design stores compressed batch payloads in cloud storage and keeps metadata in Firestore. That reduced cost and scaling pressures while still supporting core features of the platform, such as public maps, dashboards, and moderation.
One of the biggest challenges was integration. Any change in authorization and authentication, pairing, ingestion, or visibility could affect the map, the dashboard, the emulator, or the tests. We learned to keep documentation close to the code and to use the emulator workflow to exercise the platform and reproduce problems.
Yeah, and in regards to the team process and scope, as a team, what worked really well was dividing work by feature area and then integrating through GitHub. We had some pretty good CI/CD pipelines set up with automatic integration checks, code scanning checks, linting checks, etc. And I think we divided work in a way that made sense. But what did not work well, however, was early scope control. Given that this project has a hardware aspect, is full stack and user facing, we had to take into consideration a lot of different things such as auth, moderation, deployment, and extra documentation. And with that being said, we had to create all those things to have a working full app before building out certain extra features that we would think of. And that was a little challenging at times.
Across 3 terms, the project grew from a scaffold into a deployed-ready platform. The future work is field testing with real nodes, continued hardware validation, better exports and analytics, and possible expansion beyond particulate matter 2.5 to carbon dioxide and nitrous oxide. There is also a commercial path through my startup Denua Web LLC for hosting, node sales, support, and future development. Thank you to Oregon State University for the capstone structure and the ability for students to propose projects. CrowdPM gave us a realistic, full-stack project with real privacy, security, hardware, deployment, and product constraints.